this little box that's in my hand in this picture. I am probably the laziest imager that was ever born. That is no exaggeration. I've always regarded myself as an observer, a visual observer primarily. Imaging's just something I've always kind of meddled with, not to great success in the past. Basically, I'm not a massive fan of carting laptops outside at night and having wires trailing everywhere in the dark. It's led to one or two disasters in the past. Plus, I sit at a computer all day for my job, for my work, and the last thing I want to do on an evening for my hobby is to sit in front of a computer. For some strange reason, to me, there's a difference between sitting in front of a computer and sitting on my iPad or phone. That doesn't seem nearly as much like working as sitting at a laptop. So when this device appeared, and it was just over 2 years ago, this thing first appeared. This is the Mark I ASIair or ASIair from Chinese company ZWO. I was immediately sort of interested because what they claimed was that you could use this box instead of your laptop, and basically you would use a mobile phone or a tablet, Android or Apple tablet, to control all your imaging equipment. So I looked into it, and I thought, yeah, this looks quite interesting. And there's lots of these sort of solutions available now. There's several similar devices that are based on the Raspberry Pi computer. That's what this thing is basically. It's a Raspberry Pi. As I say, there's loads of different options. There's, I think, 3 or 4 different options that use Raspberry Pis, and there are other things as well. And of course, if you do want to use a laptop, there are far more options available for things like APT and Sequence Generator Pro, which kind of bring lots of different elements together. But what I really liked about this was the fact that it is so user friendly, so quick and easy to use, and well, I'll kind of explain as we go on. So this device here is the computer that controls everything. Your phone or your iPad has an app on it, which acts as an interface with this device. So it's not your phone or your iPad that's controlling everything. It's this little box of tricks. This is actually a PC with a quad-core processor. It's amazing. I mean, this cost me £100 second hand when I bought it just over a year ago. I think they were about £180 new. I think the Pro version, which has superseded it, is a little bit more expensive. I think it's about just over £300. But this is the back of the box, and we can see poking out the top a little micro SD card, and that has the operating software as well as being the storage for this particular device. The later version has the ability to plug a sort of a USB flash drive into one of the USB ports, and you can store your pictures on there. But at the end of a night, I take this card out, bring it in the house, put it into a card reader, download all the images onto my computer. I believe you can do it wirelessly if you connect this device to your home Wi-Fi network. But this is the Pro version, which I don't have at the moment. So this uses a more up to date. I think this is the version 4 Raspberry Pi that this one's based on. This one has an on-off switch, which mine doesn't have. It's very, very fancy. It also has the power control device built in to the actual box, so everything's all in one. As you'll see as we go on, mine has a separate little power inverter. This one also, as you can see on the picture on the right hand side, or along the side there, it has four 12-volt outlets, so you can actually you can power other equipment from this device as well. So you can power your mount, you can power the cooler for your main camera. I guess you could even plug dew heaters in there somehow. But it's definitely an upgrade, and the beauty of this Pro version as well is that it supports video. So you can actually do planetary imaging. You can capture planetary video images on the device. It's quick enough to do that. And it also supports live stacking. So for anybody who likes doing electronic assisted astronomy, sort of cross between observing and imaging, where you get a sort of a live image that builds up on the screen in front of you. This Pro version does all of that as well. The only thing that we've come across with the Pro version is because it's in a nice fancy metal case, the Wi-Fi range is not quite as good as with the original version, which came in a plastic case. So at the moment, I can operate my device from my phone or iPad from anywhere within my house. I might be struggling a bit with the Pro version, but there are solutions. There are ways around this by making sure you've got your home Wi-Fi router close to the device, and then you can actually connect it to your home Wi-Fi. Or alternatively, what a lot of people are doing is they're plugging a Wi-Fi range extending device, which is a similar size to this box, and it plugs into the Ethernet port, which is this thing down there. See if we can get there. Yeah, this thing here that I'm highlighting. So that's the Ethernet port. So you can connect a Wi-Fi extender to that for the Pro version. That gives you a bit more range. So this is my setup in the garden. As you can see, the device is sitting. It's basically just Velcro hoop and loop material. It's just sitting on top of the rings of the telescope. It's there quite happy. It doesn't upset the balance of the scope because it weighs next to nothing, and everything's sort of plugged into that. I've got a little video now. Get this one running. A little walk around so you can see everything up on the top. We've got 3 cables plugged into the USB ports. 2 go to the cameras, and the third one goes to my mount. So this cable here is plugged into the hand control port of the mount. It'll plug either into the hand controller or where the hand box would go on the mount itself. And the other 2 connections are to the guide camera there and the main camera. So this is the little power inverter box that I was telling you about, the little red box that's below the air. That's missing on the Pro. It's all incorporated into the device. Okay. So I use an iPad and an iPhone, but the way of operating this is exactly the same for Android. It all works through an app, which is on your device. What I've found with the guys at ZWO are very sort of proactive. They're very, very keen to sort of listen to users' feedback and update the device and incorporate changes in it. What you tend to find is that with the vagaries of the British weather, quite often it's several weeks between actually getting out and doing anything, and you might find that since you last used it, the developers at ZWO have actually made improvements to it, and they've added new features. So quite often, basically how this works is that your phone or tablet, the updates go into the app on your device, and as soon as you connect your phone or tablet to the air, when you switch it on, it downloads over the Wi-Fi, and it updates the firmware. So that's quite a common thing. I was finding for a time when I first started using this, every time I switched it on, there was an update to do, and there was new features, and the features are brilliant. They do listen to the users, and you know, they encourage people to sort of say, what would you like to see in the next release, and they add them in. So from scratch, how we do this, we power up the Air, we turn it on, we leave it for about 10 seconds for the Wi-Fi signal. It generates its own Wi-Fi network. So there is an option to connect it to your home Wi-Fi network if you want to, but you don't have to. So for use out in the field, this thing fires up its own Wi-Fi network, and that's what you can see here. This is the Air's network appearing in my list of nearby hotspots. So we just tick that, and that connects our phone or tablet to the Air. We then start the Air app, which is on the device. So I've got my ASIair app there in my little astronomy folder on my iPad. So we click and we start the Air app. We're presented with this start screen here, which has collected the latitude and longitude and time and date from your phone or iPad. It will also bring up the last devices that you had connected. So we can see over here, we've got the mount. Now I'm using a Skywatcher mount, but I use EQ mod. The reason I use EQ mod is because it's much easier, and there's no star alignments to do, and it integrates nicely with Sky Safari, the planetarium program, which I also use with the app. So when I took this screenshot, I didn't have a guide camera attached. I did have my main camera attached, so that's down here. We can see other devices. We didn't have an electronic filter wheel because I use a one-shot color camera, but the device supports filter wheels if you use filter wheels, and no electronic autofocuser either. And yes, it does autofocus if you wanted to. So that's another sort of recent development with one of the updates. It will now autofocus like an SLR camera. And apparently it works brilliant. I don't do that. I don't do a lot of things with this, to be honest. I only really use it in its most basic form. But for those that want to use the advanced features, there's stuff in there that's far more complex than I've been using. So we simply hit the enter button at the bottom right hand corner of the screen, and it takes us into the home screen for the device. And there's a lot going on here. I know it looks a bit busy, and it takes a few tries to sort of figure out what everything does. But pretty much everything on the screen is a button, and everything on the screen you can by simply touching the screen where the text or symbols are, it opens you up into some different sub menus. Displayed along the bottom, we have information about the main camera. So we can see down at the bottom at the moment the gain was set to 89. It's displaying the temperature, and my cooler was turned off. Along the top of the screen, these symbols are all sub-menus. So we got this one here. So this is the menu for the settings for the Air itself. Then we've got the main camera, the guide camera, the mount, the filter wheel, the focuser, and the micro SD card. So if we click on the first one here, the first tab, it takes us into the settings menu. If we clicked on that one, it would take us into the sub menu for the main camera. This area here is our guide trace, and we can toggle this on and off simply by pressing here. You can see where we have the guide button here. That toggles this part of the screen on and off. As you see, it's green so it's displayed. The histogram's also turned on. The histogram's down here, so that shows our image histogram. So if we click on the first one for the ASIair settings, we can see the various settings for the device. I tend to use the 5G Wi-Fi rather than the 2.4. It's faster. The range is shorter, but it doesn't seem to matter for me. It works absolutely fine. Wi-Fi station mode is if you want to connect the device to your home Wi-Fi network. That means you can actually access the internet on the device that you're using at the same time you're using it. Because obviously, if you're just using a phone or tablet with the device's Wi-Fi, you can't then access the internet from that device. Okay, so the next tab along is the main camera settings. So again, in here we can set the gain of the camera and turn the cooling on and off, the anti-dew. I've got some more settings down there for customizing file names, and the advanced settings I've never even been in there, so I don't know what they do. Our guide settings for a guide camera, I'm using another ZWO ASI 120 as my guide camera with a little finder guider scope. It's only a 32mm guide scope, works absolutely brilliant. So all your guide settings are in here. You can also dither. Dithering is where the system will between each exposure, it will move where the telescope's pointed by a few pixels. What this does is it helps with sort of things like dead pixels or hot pixels on the camera, and it stops effects like walking noise. Again, I've never used it, but a lot of people who are using this swear by that. I've never done it. Okay, so back to stays on. Okay, so we're back to the main screen. If you look at the sort of top right, you'll see the word preview in yellow. So that is another button for accessing various submenus. And if you press where it says preview, it takes you into, it gives you options for focus mode. So at the moment, preview mode will simply, it will push up a picture. Every time the big white button there on the right hand side of the screen, that's your shutter, that's your start, basically start an exposure button. By hitting that, it will at the moment it's set for a 10-second exposure. You can see below where it says EXP 10 seconds. So if we hit start, it would take a 10-second exposure and it would display it on the screen. You can then save that image if you want to by simply hitting the little down arrow button in the bottom right. That will save an image. But by hitting preview in yellow there, it takes you into one of several modes. One's focus, then there's polar alignment mode, and then what's called auto run mode. Those are your options. So the first thing I would do after starting up is go into focus mode. So by hitting preview, focus will appear, and you just hit focus, and it takes you into this screen. Now you can see the background has gone like a television that's detuned. So it's now actually it's scrolling. It's in focus mode, and it's refreshing every 1 second. What I would usually do, can you see over again, sort of on the right hand side where it says bin 1? I would usually, when I'm focusing, I would set that to bin 4, and you do that simply by pressing bin 1, and the options for bin 2, bin 3, and bin 4 appear. So are we all aware what binning is? For a start, bin 1 essentially means that every pixel on the camera represents one pixel on the screen. If we set it to bin 2, what it does is it takes a 2x2 array of pixels, so essentially 4 pixels, and turns them into one big pixel, and it throws them out. So what happens every time you increase the bin, you basically make the pixels bigger of your camera. So binning 3, you get a 3x3 or a 9 pixels becomes one array, and in the case of 4x4, you've got 16 pixels. Now, what that does is it lowers the resolution of the camera, but it increases its sensitivity, and it's particularly good for focusing because the image files are smaller, they download much quicker, they refresh much quicker, and it makes focusing so much easier. So I'd usually set that to 4, and then basically, because I like to do it manually, just start twiddling the focus knob on the telescope until you start seeing stars on the screen. So this green box here in the middle with a cross in it is basically you can just drag that to wherever on the screen. So you find a nice bright star on the screen, and you just put your finger on that and drag it over the top of it, and then hit this button over here, the plus button, and that takes us into. I'll tell you what I've done there. I've just turned this off there. Just toggled that off. That's the guiding screen. That's all I've done there. I've just toggled it off to make it less fussy. You can toggle this part of the screen off as well, just by hitting those little arrows there, and that will disappear to give you a nice big picture on your screen for focusing. So when you've found a star that you want to zoom in on, as I say, you hit this part of the screen here to plus in, and it takes you into a zoomed view. This has a couple of very, very handy tools which are very useful for focusing. I sometimes use a Batonov mask for my focusing, and that gives you a nice image on the screen of the whiskers for your Batonov mask. But it also has some technical tools over here. You can basically watch these numbers. In the case of this box, as your star gets closer to focus, the number here gets smaller and smaller and smaller. And once you've got it as small as it'll go, you're in focus. Lock your focuser off. And the next job is simply hit this button here, the back button, and it takes us back to our main screen, where we can start our polar alignment. So having focused it from the main screen, we'd hit the word up here, which will be on focus in yellow, and we'll get the options below of preview, focus, PA for polar alignment, and auto run. So we go into the polar alignment section. I love this. It's absolutely brilliant. I should mention at no point have I actually looked at the sky. All I've really done is I've plonked my telescope down on its tripod in the configuration shown in the little graphic at the bottom left, with the telescope tube pointing straight up above the polar axis. So what it actually does, we just hit this play button here over on the right hand side, and it starts to rotate the axis. What it does first is it takes an image of the area of the sky around the pole, and then it actually physically rotates the right ascension axis by about 60 degrees. And this particular screenshot was taken when it was about 3/4 of the way through that. Once it's rotated through 60 degrees, it takes another shot and presents us with this. It says, right, I've calculated now where your mount's pointing and where it should be pointing. And we say the bottom, let's go. We tap on let's go, and we get presented with this screen. So what you're looking at in the middle, the blue spot in the middle of the two circles is the northern celestial pole. That's where we want the polar axis to be pointing. And the little yellow circle with the 4 whiskers is where it's actually pointing at the time. And we've got over on the right-hand side, the figures in blue tell us how much we're out by. So as we can see, when I started here, I was out quite a bit. in azimuth. I was 7 degrees, 7 3/4 degrees out in azimuth. Bit closer in altitude. I was only 5 arc minutes too low, so not too bad. As you see, we've got a bit of a miserable face going on here over in the top right hand side of the screen. We want a smiley face, which we'll get as we get closer. So what we do is we twiddle the knobs, and it's telling us, well, we need to go up and we need to go left. So I would turn the knob. I usually sort of stand right in front of the telescope, facing the lens of the telescope. And if I want to move the mount to the left, I would turn the right hand knob and give it a couple of twiddles, and then we just hit the refresh button down the bottom here. So what it does is it takes another picture, and it tells us, well, we can see we're a little bit closer from how I've done it. We're only 4 arc minutes too low now, just over 6 degrees out in azimuth. So we'll twiddle the knobs a little bit further. We'll hit refresh again. So after, and by the way, this is a counter over here. This is a timer. So after 1 minute and 40 seconds of twiddling on, I'm only 18 arc seconds out in altitude and just over 2 degrees out in azimuth. And we can see the little yellow circle is getting closer to the green one every time. So again, we twiddle the knobs and we hit refresh, and we keep doing this. So after 4 minutes and 17 seconds, I'd got it close enough that I was happy with. I've got a nice smiley face here now. As we can see, we're only out by 14 arc seconds in azimuth and 2 arc seconds in altitude. Overall error 8 arc seconds, which is nout. So we have 2 options at the bottom now of finish or refresh, because we can carry on if we want to. If we're not happy with an error of 8 arc seconds, we can carry on twiddling away to our heart's desire. And I think the closest I got it was down to about 2 arc seconds. In all honesty, the device is more accurate than the knobs on your mount for twiddling it and your fingers. And it's pretty much sort of trial and error getting it down to 0. So I was quite happy with that. So I hit OK. So it gives us a little fireworks display to tell us we're finished. So we're focused, we're polar aligned. The next thing we do is choose our target and go to. Now the device has a number of databases built into it. We access those through this part of the screen here, and we just basically click in that box there, and it opens us into the screen that you can see on the right hand side. What it lists is the evening's best objects. So it picks targets that are nice and high up at the time that you're observing. But we've got menus for messier objects, NGCs, Caldwell's. And it's growing all the time. Basically, they're going whatever people want. They're adding things all the time to the database. So we simply select the thing we want and click choose over in the top right hand corner of this screen, and it takes us back to the main screen, and we hit the go to button, which is highlighted in green. This one here. So we hit go to, and off it goes. And in this case, I was slewing to M15, the globular cluster. So what it's doing here is it's slewing automatically. I've not had to do any alignment. Now, traditionally, when I was imaging, before I could start imaging, you'd have to do an alignment on the mount by pointing it at 3 stars. Don't need to do that at all. From the polar alignment routine and the pictures that it's taken, it's plate solved. It knows exactly where it's pointing, and it goes to where it thinks M15 is. But it doesn't stop there. As you can see on the screen there in the white box in the middle, it says validate centered or not. So when it's slewed over the position, it takes a picture and compares it. So as we see, it's taken a picture and it says it's uncentered, retry once. My experience with this is that sometimes it hits it first time. It never fails to hit it the second time, all the times I've used it. So it only needs one retry. But that's the beauty of plate solving is it will put your target bang in the center wherever you want it. So after its retry, you see there it says target is centered, and it takes a short exposure and throws it up on the screen just in case you don't believe it. Okay, so we've now centered our target. A really neat feature of one of the updates to the software was something called Center Here. I was discussing this with Paul yesterday. If you don't particularly want the target centered, and there are lots of reasons why you might not want the target centered. One of them being particularly if you're wanting to take a picture of a comet, which is passing by another interesting object, and you might want to frame it so that both objects are in the field of view. You can tell the device where on the screen you wanted to set the center, and we do this simply by holding our finger on the preview image that it's just thrown up. And a little green target appears and it says click here to center. So you just click on the screen again and it slews the mount to put that point as the center of your photograph, which I think is really, really neat. So the next thing we do, we go and we set up our imaging sequence, and we do that from the yellow text again at the top right. So we see preview, we tap on preview, and we go into the auto. Oh, sorry, I've missed a step out, haven't I? Guiding. You do the guiding first. Right. So it has a version of PhD, which a lot of people will be familiar with. It has this built into it. So if you've used PhD before, and I've used PhD, and I've found PhD a bit unreliable, and I've found this guiding to be super reliable. It just works. It's great. So this is a view from the guide camera. See lots of stars. I've chosen the bright one which is in the box below. As soon as you pick your guide star, it puts a green box around it. So setting up guiding is very simple. You simply work your way down these icons down the right hand side. So by hitting the I, this allows you to clear any previous guiding calibration, which is they recommend you do that. Because every time you move to a different part of the sky, the weight distribution of the equipment on the mount changes, and it alters the guiding characteristics. So they do recommend every time you move to a new target, if it's a long way away from the previous one. And I do this every night. I always clear the previous guide calibrations. So having done that, we move down one. This is the loop button. This simply starts your guide camera throwing up an image every 2 seconds on the screen for you to choose your guide star. So we choose our star. I've chosen that one at the bottom, and then we hit this button here, which is the guide button, and then it does its little alignment calibration. That's what it's doing now. This screenshot was taken while it was calibrating. It does this all automatically. You just sit and watch it do it. So what it does is it moves the guide star south so far, and then it moves it back to north, and then it moves it up, and then it moves it down again. And what it's doing is it's figuring out the steps of the mount, of how far each little prod that it gives the mount will move the star, and it'll then remember those settings for when it's guiding. So it will automatically start guiding once it's finished its calibration. These two yellow cross wires that you see will turn green, and that's it. You're done. So we simply hit the back arrow to take us back to the main page. There's a close up of the guiding. That's it when it's actually working. So We can see all the corrections along the bottom here. You'll see I was getting quite nice guiding, average of about half an arc second. Not too bad. Okay, so we can now go in and set up our schedule of shots. We can tell it how many exposures we want it to take and how long we want them to be for. We can tell it we want to do lights and darks and flats and dark flats and bias and whatever else. In this screen also we have the ability to turn meridian flip on and off. Again, I don't use this, but lots of people do, and they swear by it. And when that's turned on, it will do an automatic meridian flip. It'll recenter your target, obviously pause your shooting, recenter, start the guiding up again, and then start your image sequence back off again. As I say, I don't use it, but it's there for those who want to. So by clicking on this box here, it opens us up into a box here where we can tell it what we want to do. So we've got our exposure length, the number of exposures we want, and what we're actually doing. And we click OK. This is just to show you the image file. So it puts everything into folders according to the object that you've chosen. So it names them automatically for you. So when you go back later on, you can see they're all in there in nice little neat folders. And within each folder, you can preview all the images that you've taken. If you're like me, I like to just sort of monitor it. I just like to watch them coming in, and if there's any that are rubbish for whatever reason, if a plane's gone through or a cloud's gone over and the sub's no good, you have the option to immediately delete it there and then. So we've done our focusing, we've done our polar alignment, we've gone to our target, we've set up our guiding, we've set up our imaging sequence. We then hit the start button, which is the big one. At the moment, you can see it's a pause button because I've already done it. So this was, as you can see, the witch's broom, and you've got your guiding plot along the bottom, so you can watch what's going on with the guiding as the thing progresses. But essentially, this is where all the best bit happens, really. And you just watch the images come in, one after the other. As I say, I'm a bit neurotic with it, so I tend to sort of I tend to monitor it. I tend to sit with the iPad on my knee and watch all the images come in one by one. But this particular imaging sequence was 20 images long. And 300 seconds, so 5 minutes, 20 of them. As you can see, when I took this screenshot, it had taken 18 of them, so I was coming towards the end of the actual imaging run. But that's basically it. It's taken, believe it or not, it's taken me longer to explain that than it would have to just show you on the screen. If I'd been able to just take this outside and do it, we'd be at this point now where we're getting our first image. I reckon it would have probably taken about 10 minutes from basically having a telescope that isn't polar aligned to getting our first image down. I reckon it would have taken about 10 minutes. And we'd be at that point. So yes, five minutes to set everything up, go to the target, set the guiding up. That's how quick it is, which is phenomenal. So I'll show you a few images that I've taken with it over the summer and also far the autumn. Mm-hmm.
Can I ask a question?
Yeah.
I know it makes not a heap of the difference, but on the guiding graph,
yeah,
can you adjust the range so that it looks smoother?
It tends to adjust itself automatically, David, as you're going. I don't know is the answer to that. You may be able to. I know if you go into the guide screen, go back to here. If you go to here, you get a. I mean, I've learned to ignore the sort of
graph,
the graph, the ups and downs, and just look at the numbers. And since I've been using this, I've not had any problem with guiding at all. I mean, sometimes it wanders over 1 arc second at various points on the worm of the RA drive. You can turn the corrections for declination off if you want to, and to be honest, there's no reason why you need them on with shortish exposures and a very, very well polar aligned scope. You really only need to be correcting in RA. But what you find on the main screen is that the guide graph it changes. It changes the scale depending on how it's doing, how it's getting on. So that's it in a nutshell. It's so quick and so easy to use. And this was the final result of that shot. So this was taken from home. That was 25-minute shots through that Optolong LX Stream filter that I picked up recently. It's quite nice. I can't remember a sort of a period ever where I've collected so many images in such a short space of time, and it's through the ease of setup really. So the other half of the veil, this is the flying bat nebula, I think they call it sometimes, don't they? Or the bridal veil nebula. Again, from home with the LX Stream filter. Elephant's trunk. Yes, I think that was again from home here. Another one.
Graham, can I just ask a question about framing?
Yeah.
I use APT and it links Stellarium. So once it's plate solved and you've got the image in the middle or exactly where you want it to be, you can then, even though the picture might just be a 3 or 4 second exposure, so you can't even see the target you're imaging, it will send information so that you can then view it in Stellarium with your setup to see whether or not you need to rotate your camera, because you might have it while you might have it framed right, you might want to rotate your camera around. Is there any facility in here that does that kind of thing?
I connect mine to Sky Safari. It does the same thing.
It does the same thing. So it lets you know in Sky Safari, so it'll say this is how
this is where you're pointing. I mean, I'm sort of all new to this whole plate solving thing, but I'm an instant convert because it's so good that you know the thing just puts your target where you want it. It's great, but this particular image of NGC 7331 and Stefan's quintet, I used the center here function for this one. So I sort of clicked somewhere off to the sort of upper right of NGC 7331. So that's where I wanted, because I want obviously both of these galaxy groups in the frame. So it just does it, which is great. I've done some double star imaging from home as well with the Air. So these are Eta Cassiopeia 57 Aquila, 100 Hercules, and try to remember the last one. Can't remember the last one. But I'm busy on sort of doing a lot of these from home at the moment. I'm building up a bit of a sort of a library of double star images. I've also been fortunate enough to have a lot of clear skies at the caravan this autumn. Unusual for the Lake District for it to be so clear so often, but I had 2 weekends in a row, sort of either side of new moon in September, where I think I got about seven or eight images over the space of the 4 nights. It was clear on the Friday and Saturday night over both weekends at the caravan. Portal 3 site, nice and dark. So I was able to.
You're not making us like you at the moment.
I know. I couldn't believe. I mean, I couldn't believe my luck that I got 2 nights in a row. Never mind 2 weekends with 2 nights in a row. But it was staggering. So this was taken from a dark site. This was from the caravan, the North America Nebula, through the LX Stream filter. This was I think this was about 28 5-minute exposures stacked. So I'm quite happy with that one. M33 again from the caravan, no filter at all other than an IR UV cut. By the way, all of these images, other than the ones of the Galaxy clusters, were taken with the little 71mm quad. The Galaxy cluster one was taken with the Tech refractor. This is Scutum Star Cloud. The cluster on the far right is the M11, the Wild Duck cluster. There's several Barnard dark nebulae in the frame on this one. It's just absolutely peppered with stars, that area of the sky. This was the Iris Nebula. This was probably, I think, the longest exposures I've ever done. This was about 34 5-minute frames. Just over, I think, 2.5 hours, something like that, of exposure time. Nothing compared to what other people do. And I know, there's probably people watching this who are saying 2.5 hours, that's nothing. That's a long time for me. You've got to remember I'm the world's laziest imager. I'm used to taking a single 2-minute shot and then processing the life out of it and saying, there you go, finished.
That's nice, I agree with all the colours.
There's nothing wrong with that image.
No, I was pleased with that one. Very pleased with that one. Ghost of Cassiopeia. Again from the caravan. No filter at all with this one. It's a good sky. I mean, it is nice and dark. Double cluster. Again from the caravan. No filters on that one again. The end.
Oh.